Good morning, students. Myself, Krishnendra Sahu, Assistant Professor in the Bose Engineering College, Cuttack, Odisha, from Department of Electrical Engineering. Last class, आमे block diagram regarding details discussion करथिले. Block diagram कोन? Block diagram केमती draw करा जाए in electrical circuit. A system is given. How हम draw करथिले block diagram. That part we were discussed in the last class. किंतु आजी आमे discussion करिबा block diagram reduction. Block diagram means last class तो मानन कहितली जदि गोटे कंट्रोल सिस्टम थी लेट यू कंसीडर ए ऑटोमोबाइल लेट बाइक यू रन ए बाइक व्हेन यू रन ए बाइक इज ए प्रिपेयर ए कंट्रोल सिस्टम बाइक गोटे आम कंट्रोल सिस्टम करे बाइक रे कौन अच्छी एक्सेलरेटर ब्रेक इंजिन एंड द ह्यूमन बॉडी हु इज सिटिंग इन द बाइक इन द ह्यूमन हेड एवरीथिंग इज प्रिपेयरिंग ए control system. Total is a control system. Means bike riding is a control system. Total is a control system because it is control, so that we can reach a proper place by using bike. Okay. In the bike system, if I open my eye, that is known as a closed loop control system. Because I look the bike wheel, ମୁଁ ସବୁବେଳେ bike wheel की देखुଥାଏ रास्ता को देखुଥାଏ जहाँ द्वारा ମୁଁ proper जगह पहुँच पारि. That is a signal is coming from bike wheel. रोड गोटे सिग्नाल आम आखिकी आसे एना आम मुंडर गोटे सिग्नाल आसे हाथ को हाथ गोटे सिग्नाल आसे पाद को और हाथ को सो दैट आम एक्सीलेटर बढ़ाती कि ब्रेक मारती. सो बाइक सिस्टम इज प्रिपेयरिंग कंट्रोल सिस्टम आम से सिस्टम जो रिप्रेजेंट करवा ग्राफिकाली सो एट दैट टाइम प्रत्येक एलिमेंट को आम गोटे ब्लॉक रिप्रेजेंटेशन करवा. ईच एलिमेंट इज रिप्रेजेंट ए ब्लॉक एंड दैट ब्लॉक कंटेन्स द ट्रांसफर फंक्शन ऑफ दैट एलिमेंट. ओके मीन्स प्रत्येक कंट्रोल सिस्टम को आम रिप्रेजेंट करवा डिफरेंट ब्लॉक रे रिप्रेजेंट करा जाए एवं प्रत्येक एलिमेंट ऑफ द कंट्रोल सिस्टम और सिस्टम दैट रिप्रेजेंट बाय ए ब्लॉक एंड ब्लॉक कंटेन्स द ट्रांसफर फंक्शन ऑफ दैट एलिमेंट. सो दैट ब्लॉक डायग्राम इज नॉट ए डिटेल्स अबाउट द कंट्रोल सिस्टम. ब्लॉक डायग्राम आम गोटे कंट्रोल सिस्टम डिटेल दे पारिबनी व्हिच टाइप सिस्टम इट इज द स्ट्रक्चर ऑफ ए सिस्टम. जमती मनुष्य बॉडी स्केलेटन सिमिलरली गोटे सिस्टम को रिप्रेजेंट करने ब्लॉक डायग्राम गोटे मेथड इट रिप्रेजेंट द स्केलेटन ऑफ ए सिस्टम. ओके वेयर ब्लॉक इज इंपोर्टेंट पार्ट. लास्ट क्लास तुम कही ब्लॉक एवं तार समिंग पॉइंट देन इट टेकअप पॉइंट दीज आर द इंपोर्टेंट पार्ट्स ऑफ ए ब्लॉक डायग्राम. ओके तेणु गोटे कम्प्लेक्स सिस्टम जो ब्लॉक डायग्राम दे थाए आम ताको रिड्यूस करवा केमिति. प्रकृत में गोटे ब्लॉक डायग्राम रे जो ट्रांसफर फंक्शन थाए दैट इज द ट्रांसफर फंक्शन ऑफ दैट ब्लॉक और पर्टिकुलर एलिमेंट. किंतु गोटे कम्प्लेक्स सिस्टम देयर आर सो मेनी ब्लॉक्स आर देयर एवं प्रत्येक ब्लॉक रे कौन थी ट्रांसफर फंक्शन. प्रत्येक ब्लॉक कंटेन्स ट्रांसफर फंक्शन. आमर यदि क्वेश्चन थी फाइंड द टोटल ओवरऑल ट्रांसफर फंक्शन और इक्विवेलेंट ट्रांसफर फंक्शन ऑफ द होल सिस्टम. एट दैट टाइम जो मेनी ब्लॉक्स आर कनेक्टेड इन द कंट्रोल सिस्टम सब ब्लॉक आम केमती रिड्यूस करके गोटे सिंगल ब्लॉक करिपरिबा. सिंगल ब्लॉक हेले आम लास्ट क्लास तुम पिला कही तुम सिंगल ब्लॉक जना थी से सिंगल ब्लॉक रो इनपुट सिग्नल आउटपुट सिग्नल एंड ब्लॉक वैल्यू द ट्रांसफर फंक्शन. तेणु आम डिस्कसन आज करवा से ब्लॉक गोटे कम्प्लेक्स सिस्टम रो डिफरेंट ब्लॉक्स थे आम रिड्यूस करके सिंगल ब्लॉक रिप्रेजेंट करवा दैट इज आवर टॉपिक. ओके दैट्स व्हाई टुडे टॉपिक इज block diagram reduction. Okay, in the block diagram reduction today we will discuss about why you draw the block diagram and what is the procedure to draw the block diagram, rules for the block diagram and simple problems. I solve some simple problems such that in the problem you can find the transfer function or overall transfer function or equivalent transfer function of a block diagram for a complex system. Okay. So first discuss about why block diagram reduction is required. You see, ମୁଁ तुम बर्तमान कहली गोटे कम्प्लेक्स सिस्टम आम रिप्रेजेंट करवा ब्लॉक डायग्राम रे देयर आर सो मेनी ब्लॉक्स आर देयर. जदि गोटे ब्लॉक डायग्राम फिगर रे सो मेनी ब्लॉक्स थी प्रत्येक ब्लॉक्स भीतर आम कौन थी ट्रांसफर फंक्शन. इच ब्लॉक कंटेन्स द ट्रांसफर फंक्शन. सो यू सी इफ दिस इज ए ब्लॉक हियर लुक टू हियर. सो इफ दिस इज ए ब्लॉक हियर दिस इज द input signal that is RS, this is the output signal that is CS and the block contains the transfer function GS. Okay. Here you see transfer function of the block is equal to transfer function output signal of Laplace of output signal by Laplace of input signal, Laplace of output by Laplace of input CS by RS, that is called transfer function of a block and that block value is nothing but that is equal to GS. GS is the transfer function. For this block, GS is the transfer function. Means प्रत्येक block रे जो value था that transfer function is the transfer function of that element. यही block टा जो element पाए represent करूँची से element रे transfer function टा block भीतर लिखा जाए एवं प्रत्येक element को उड़े signal जाए एवं उड़े signal output करे. तो RS is the input signal, CS is the RS is the input signal, CS is your output signal. And this RS is the Laplace of a input signal. Actually, input signal is RT. You see, students, input signal is RT. Time form, so Laplace is RS. Similarly, output signal is CT. Time form, output response. And the Laplace form is CS. The Laplace of output CS by Laplace of input RS, CS by RS, that is called transfer function. And transfer function is nothing but for this block, it is equal to value of GS. Means प्रत्येक block भीतर जो value टा था that is the transfer function of that block or of that element. Okay. किंतु जितने for complex system भीतर हमारे कौन था पिला माने उटे complex system वाला so many blocks are there. क्या ना बहुत element था उटे complex system so many blocks are there. तो so many blocks the connection थिबो जो question थिबो find the equivalent transfer function or overall transfer function of this system. Total system रे गोटे input signal थिबो, गोटे output signal थिबो. So Laplace of output, Laplace of input for the total system, that is equivalent transfer function or overall transfer function. आम सेठी बाहर करला बेले हमको problem होबो कोना so many blocks थिबो. आमे केमिति जे so many blocks can reduce a single block by the method of block diagram reduction method. You see here, it is the technique by which we can determine the overall or equivalent transfer function of a complex control system where number of blocks are connected. Okay, this is the definition here. Okay, then we will go here. Then we discuss about rules for block diagram reduction. Rules means procedure. What is the procedure? Okay, to draw the block diagram reduction means if the so many blocks are there, how you reduce into a single block? There are some rules are there. That rules are called as rules for block diagram reduction. And there are 10 rules are required for the block diagram reduction in a complex control system. There are 10 rules are there. Rule 1 to rule 10, there are 10 rules are there. By applying these 10 rules, we can reduce a complex control system which many blocks to become a single block. Many blocks we convert kari single block, reduce kari by using these 10 rules. Okay, these rules are here, you see. So, rule number 1, you see, rule number 1 means when the blocks are cascade. Block or cascade means, students, cascade in parallel, back-to-back connection. If blocks are back-to-back connection, you see here, if blocks are back-to-back connection, if you see, there is a block here, there is a block here. Two blocks are back-to-back connection. So, this is the input signal is RS, output signal is. So, this system contains two blocks you see. Okay. So, first block has a block transfer function G1s, second block has block transfer function G2s. Okay. So, this is the output of a first block. You see here. So, let the signal is C1s. Okay. C1s. You see. Means see, in this system two blocks are there G1s, G2s, they are cascade connected or back-to-back connection. For first block, transfer function G1s, for second block, transfer function G2s. And for the two blocks or two total system, input signal is RS, output signal is CS. And from first block, the output is C1s, that is also input to the second block. Second, first block ko jota pila mane bahar che output signal dekho C1s, second block ro seta hoche input signal. এবং ইনপুট সিগনাল কেতে টোটাল সিস্টেমর RS, টোটাল সিস্টেমর আউটপুট কেতে CS. এটি দুইটা ব্লক কাস্কেড কানেকশন আছে. কাস্কেড মিন্স প্যারালাল. কাস্কেড ইজ অদর ব্যাক টু ইট ইজ সিরিজ কানেকশন. কাস্কেড অলসো কল্ড এজ সিরিজ. Similar to or series. Back to back connection. When the blocks are back to back connection. What happens here? If two blocks are consider two blocks here, cascade connection, G1s, G2s. If two blocks are cascade connection, you see, when two or more blocks are cascaded, here two blocks are here, sometimes three blocks are cascaded, sometimes four blocks cascaded, means back-to-back connection or series connection. Okay. When two or more blocks are in cascade, the resultant block transfer function is the product of individual block transfer function. Means you see, if for first block, the transfer function is G1s, second block, transfer function is G2s, then the total block transfer function of this system or overall transfer function or equivalent transfer function with two blocks is equal to G1s into G2s, G1 and into G2s. Just multiply. Two blocks are series connection or cascade connection. So G1s into G2s. Individual block transfer function you multiply so that you get the overall block transfer function of the two blocks when they are cascade connection. Means you see here the transfer function is equal to nothing but you see a transfer function Cs by Rs is equal to you see G1s into G2s. Here in the overall transfer function is the multiplication transfer function of the multiply G1s into Gs. The each block transfer function you multiply so that you will get the resultant block transfer function of a cascade connection. You see here. How? You just prove here. I just prove here. You see. So this first figure you see. What is the first figure? In the first figure you see C1s by first figure Rs is equal to G1s. For first block you see what the input signal Rs, for the output signal C1s. So what is the transfer function? First block C1s by Rs is equal to G1s. Similarly, for second block you see what is the output signal Cs, for the input signal C1s. So what is the transfer function? So Cs by C1s second block is equal to G2s. Okay. So if you multiply, you see this equation multiply. If you multiply, you see, so C1s C1 cancel. So you are getting, you see, C1s by Rs for first block. For second block, Cs by C1s is equal to how much? Multiply G1s into G2s. Okay. So first block of transfer function formula C1s by Rs la G1s, second block transfer function Cs by C1s G2s. Multiply कर दो दिरा. Multiply plan देखो C1s cancel. So this implies Cs by Rs is equal to G1s into G2s. That is the resultant block transfer function when two blocks are cascade. If two blocks are cascade, then the resultant block transfer function or overall block transfer function is equal to the product of each individual block transfer function. Means G1s into G2s. That is the rule 1. You see, next we go to rule 2. If you discover rule 2, you see, so rule 2 is here, rule 2. Rule 2 means when the blocks are in parallel, sometimes what happens, 2 or 3 more blocks are parallel. Parallel means they are connecting a summing point. You see, just I am taking example here, a figure is here, you see. So here is a summing point here. So you see, so it written that, you see when 2 or more blocks are connected in parallel, the resultant block transfer function is the sum of individual block transfer function. Here, if 2-3 blocks are parallel, the resultant block transfer function equal to the sum of each individual block transfer function. Here, 3 block यदि parallel थिबे, आमे ता resultant of transfer function केता हबो ना प्रत्येक ब्लॉक रो जे ट्रांसफर फंक्शन सब मिसै देबा किबा सबट्रैक्ट करबा अकॉर्डिंग टू द सिग्नल. यू सी when 2 or 3 more blocks are parallel connection, the resultant block transfer function ता resultant block transfer केता हबो ना प्रत्येक ब्लॉक रो जो ट्रांसफर फंक्शन दिबो ताके हम ऐड कर देबा. या पूर्वटा कास्केड थिला, कास्केड कोन करथिला हम मल्टीप्लाई करथिले. पैरेलल केस रे हम ब्लॉक ट्रांसफर फंक्शन इंडिविजुअली हम यदि ऐड कर देबा हम पाई जिबा ओवरऑल ब्लॉक ट्रांसफर फंक्शन ऑफ द होल सिस्टम. You see here, consider 3 blocks in parallel. So I am discussing here when 3 blocks are parallel. You see here, 3 blocks are parallel. So you see, this is a block 1, a connecting a summing point here. This is block 1. This is block 2. This is block 3. 3 blocks are here. 3 blocks just here. I have drawn the parallel. And 3 blocks are supplying the signal to a summing point, you see here. Because last class I told you if more signals are given to a particular point, use a summing point. Means more signals you added. If more signals you added, want to add, then use the summing point. So for the, let the input signal is equal to how much? Input signal is equal to Rs. The output signal is Cs. First block transfer function value is G1s. Second block transfer function is G2s. Third is G3s. You see, G1s, G2s, G3s. Okay. Let this signal is equal to first block plus, ये भी positive, all are positive signals. Positive here. All signals in a positive value. Okay. So you see here, 3 blocks are parallel. First block transfer function G1s, second block transfer G2s, third block transfer G3s. All 3 blocks are parallel. So at that time what happens? The resultant block transfer, आमे ता गोटे block कर दवा, 3टा block आमे गोटे block कर दवा, पाई जबा resultant block transfer.